To convert 60 Hz to 50 Hz, there are different approaches depending on whether the device operates on alternating current, or AC power, or direct current, or DC power. For devices that operate on AC power, you can use a step-down transformer. Firstly, purchase a transformer with a primary voltage designed for 60 Hz and a secondary voltage suitable for 50 Hz. Secondly, connect the primary side of the transformer to the 60 Hz power source. Thirdly, connect the secondary side of the transformer to the device you intend to use at 50 Hz. For example, you might have a transformer with a primary voltage of 120 volts at 60 Hz and a secondary voltage of 120 volts at 50 Hz. For devices that operate on DC power, the process involves more steps. Firstly, rectify the AC power. Use a rectifier to convert the AC power to DC power. Secondly, remove the filtering capacitor to create a pulsating DC waveform. Thirdly, convert the pulsating DC to 50 Hz AC. Use an inverter to convert the pulsating DC waveform to a 50 Hz AC waveform. Fourthly, connect the output of the inverter to the device you want to use at 50 Hz. For example, you might have an input voltage of 120 volts at 60 Hz and an output voltage of 120 volts at 50 Hz after the conversion. It's important to note that the frequency of the converted power may not be exactly 50 Hz due to circuit limitations. Furthermore, some devices may not be compatible with different frequencies and may malfunction or be damaged if converted. Always consult the manufacturer's guidelines before attempting any conversion to ensure compatibility and safety. Transformers are generally used to change voltage levels, stepping them up or down, while maintaining the frequency. However, in this specific context, a specialized transformer is used to maintain voltage while facilitating a frequency conversion from 60 Hz to 50 Hz. This is crucial because many devices are designed to operate efficiently and safely within a specific frequency range. If the frequency is significantly different, the device may not function correctly or could even be damaged. Rectification is the process of converting AC voltage to DC voltage. A rectifier typically uses diodes to allow current to flow in only one direction, thus converting the alternating current into a direct current. However, this direct current is often pulsating, meaning it varies in magnitude. Filtering capacitors are commonly used to smooth out these pulsations, providing a more stable DC voltage. Removing the filtering capacitor results in a pulsating DC waveform, which is then used as an input for the inverter. An inverter is an electronic device or circuitry that converts DC voltage to AC voltage. In this case, the inverter takes the pulsating DC waveform and transforms it into a 50 Hz AC waveform. Inverters use various techniques, such as pulse width modulation, to control the frequency and voltage of the output AC signal. The quality of the output waveform can vary depending on the design and components used in the inverter. When dealing with frequency conversion, several potential issues can arise. Firstly, the output frequency might not be exactly 50 Hz. Circuit limitations and component tolerances can introduce variations in the output frequency. Secondly, the voltage and waveform of the converted power may not be identical to the original. This can affect the performance and reliability of the device being powered. Thirdly, some devices are highly sensitive to frequency variations and may not function correctly or could be damaged if the frequency is outside their specified range. For example, motors and timing circuits are often frequency dependent. Therefore, it is crucial to consult the manufacturer's guidelines or technical specifications before attempting any frequency conversion. The manufacturer's documentation will provide information on the device's operating frequency range, voltage requirements, and any potential compatibility issues. They may also offer specific recommendations or warnings regarding frequency conversion. Ignoring these guidelines can lead to damage to the device, voiding warranties, or even creating safety hazards. When selecting a transformer for frequency conversion, several factors should be considered. Firstly, the primary and secondary voltage rating should match the input and output voltage requirements. Secondly, the transformer should be rated for the appropriate power level to handle the load of the device being powered. Thirdly, the transformer should be designed for frequency conversion and have good efficiency to minimize energy loss. The efficiency of a transformer is the ratio of the output power to the input power. A higher efficiency rating indicates less energy is lost in the form of heat. When using a rectifier and inverter for frequency conversion, several factors should also be considered. Firstly, the rectifier should be capable of handling the input voltage and current. Secondly, the inverter should be capable of producing the desired output voltage and frequency with a stable and clean waveform. Thirdly, the rectifier and inverter should have adequate cooling to prevent overheating. Overheating can damage the components and reduce their lifespan. Additionally, the components used in the rectifier and inverter should be of high quality and rated for the intended application. Low-quality components can be unreliable and may fail prematurely. It is also important to ensure that all connections are secure and properly insulated to prevent electrical shock hazards. Working with electrical power can be dangerous, and it is essential to follow all safety precautions. Always disconnect the power source before working on any electrical equipment. Use appropriate safety gear such as insulated gloves and safety glasses. If you are not comfortable working with electrical power, consult a qualified electrician. They have the knowledge and experience to perform the conversion safely and correctly. Before attempting any frequency conversion, it is also advisable to research the specific requirements of the device you intend to power. Some devices may have built-in frequency conversion capabilities or may be designed to operate over a wide range of frequencies. In such cases, no external conversion is necessary. Other devices may require specific modifications or adjustments to operate correctly at a different frequency. This information can usually be found in the device's user manual or technical specifications. Furthermore, it is important to consider the potential impact on the device's performance and lifespan. Operating a device at a different frequency may affect its efficiency, accuracy, or reliability. It may also shorten its lifespan or increase the risk of failure. Therefore, it is crucial to weigh the benefits of frequency conversion against the potential risks and drawbacks. In some cases, it may be more practical or cost-effective to replace the device with one that is designed to operate at the desired frequency. This eliminates the need for frequency conversion and ensures optimal performance and reliability. In addition to the electrical considerations, it is also important to be aware of any regulatory requirements or standards that may apply to frequency conversion. Some countries or regions may have specific regulations regarding the use of electrical equipment at different frequencies. It is essential to comply with all applicable regulations to avoid legal issues or safety hazards. Failure to comply with these regulations can result in fines, penalties, or even the confiscation of equipment. Therefore, it is advisable to consult with local authorities or regulatory agencies to determine the specific requirements in your area. In summary, converting 60 Hz to 50 Hz involves different approaches depending on whether the device operates on AC or DC power. For AC devices, a specialized transformer can be used to maintain voltage while facilitating frequency conversion. For DC devices, rectification and inversion are required to convert the AC power to DC and then back to AC at the desired frequency. However, it is crucial to consider the potential risks and drawbacks of frequency conversion and to consult the manufacturer's guidelines before attempting any conversion. Always prioritize safety and follow all applicable regulations and standards. By carefully considering these factors, you can ensure that the frequency conversion is performed safely and effectively. Remember to choose the right equipment for your requirements, and always check with a qualified electrician if you are not comfortable with electrical work. By understanding the principles behind frequency conversion and taking the necessary precautions, you can successfully adapt your devices to different power systems. Consider this information as a guideline and always be mindful of the particular requirements of your specific device. Before making any decisions, remember safety should be your number one concern, and consulting with a professional is always a reliable course of action.